Hi everyone, welcome to this channel. I have named this channel Math Cafe because I want to help everyone to learn math in a way that is both relaxing and enjoyable. Because many people thought that math is boring, and whenever they talk about math, they will think that it is related to tests or exams, which is stressful. However, if you can relate what you have learned in math to the real world, then math can be very, very fun. So, at this moment, let me welcome you. Why not we grab a cup of coffee, sit back, relax, and let's explore the beauty of mathematics together. The first topic that we are going to look at is the real number system, which is a very important number system in mathematics. So what is the real number system? The real number system is a collection of numbers, and we are using these numbers widely in our daily life as well as in mathematics. And as I said, the real number system is such a large number system in mathematics, so it is being subdivided into several number sets. Don't worry if you do not understand these terms yet. I am going to explain them one by one in a minute. Okay, these number sets are the natural numbers, the whole numbers, the integers, as well as the rational numbers and irrational numbers. All these are part of the real number system. Examples of real numbers are pi, 14, -7, 1/4, or 2.5. All these are examples of members of the real number system. And the key to understand the real number system is how to attribute these real numbers into these aforementioned number sets within the number system. First, let's talk about natural numbers. Natural numbers are numbers that exist naturally in this world. And these are the numbers that we first learned from our parents when we started counting. Remember, our parents taught us how to count one apple, two apples, three apples, and so on. Because these numbers occur naturally in our world, therefore they are called natural numbers. So the set of natural numbers contain 1, 2, 3, 4, 5, and it continues until very, very large. But you might ask me, is 0 a natural number? The answer is no. Because mathematicians thought that the concept of nothing does not exist naturally in this world. It is human who invented this concept. Therefore, 0 was excluded from the natural number set. Therefore, remember that the set of natural numbers does not contain a 0 in it. If 0 is not a natural number, then what number set does 0 belong to? The answer is 0 belongs to the set of whole numbers. The set of whole numbers start from 0 and it contains all the natural numbers. Therefore, the set of whole numbers are 0, 1, 2, 3, 4, 5. This is the set of whole numbers. The third set of numbers is known as the integers. So now we have whole numbers which starts from 0 and contains all the natural numbers. That is 1, 2, 3, blah, blah, blah. However, soon afterwards, human beings thought that it's not enough to just have whole numbers. Therefore, they invented a twin brother for each natural number. So 1, they give a twin brother to 1. That is known as -1. 2, they give a twin brother, -2. And 3, -3. So the set of all the negative whole numbers, 0, as well as all the positive whole numbers, is the set of integers. An application of integers is that when you go to Japan on one day, the temperature is very low. It is as low as -7 degrees Celsius. So -7 is a member of the integer set. Now we have looked at all the whole numbers as well as the integers. So now we look at fractions as well as decimals. And another name for fraction is known as rational numbers. So all the fractions are members of the rational number set. Because all the fractions is able to ration something among people. For example, during a party, you have a pizza. You cut the pizza into 4 shares, and each person get 1 share. So 1/4 is a rational number because it is capable of rationing something among people. As mentioned, all the fractions are members of the rational number set. For example, 1/4, 3/8, and 2 and 2/7, because all fractions are capable of rationing something. How about decimals? Are decimals rational numbers? The answer is not all the decimals are rational numbers. Only 2 kinds of decimals are rational numbers. The first one is the terminating decimal, and the other one is the repeating decimals. Let's look at it one by one. Terminating decimal, for example, 0.25, because it contains only 2 decimal places. It does not contain infinite number of decimal places. Therefore, this is known as terminating decimals. All terminating decimals are able to be written as fractions. For example, 0.25, we can write it as 1/4. Or another example is 0.375, we can write it as 3/8. So this kind of decimal, that is the terminating decimals, they are rational numbers because they are essentially they are fractions. The other kind of decimals are the repeating decimals. For example, 0.33333, which goes forever, or we can write it as 0.3 with a dot on top of the digit 3. Because all repeating decimals are able to be written as fractions, in this case we can write it as 1/3. So all the repeating decimals are essentially fractions. Therefore, they are members of the rational numbers. And the fourth kind of rational numbers are all integers. Believe me or not, because for all the integers, you can simply over it by 1. For example, 8, you can write it as 8 over 1. For -99, you can write it as -99 over 1. Therefore, all integers are also members of rational numbers. Therefore, remember that the following 4 kinds of numbers are rational numbers: all the fractions, all the terminating decimals, all the repeating decimals, as well as all the integers. So we have identified all the rational numbers. So are there numbers that are not rational? The answer is yes. The numbers that are not rational are irrational numbers. And these are the numbers that cannot be written as fractions. And they contain all the non-terminating and non-repeating decimals. For example, if you take the square root of a non-perfect square, you get a non-terminating decimal. In this case, 1.4142135, blah, 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 which goes forever and ever non-stop. For this kind of decimals, you can write as fractions, though they are irrational. Some of the important mathematics constants, such as pi, which is, okay, see this guy, he is trying to write out the decimal of pi, which is 3.14. No matter how many digits he writes, he still cannot write it fully on the board. So pi is an example of irrational number. How about for e? E is also, which is widely used in physics. Okay, it is 2.718 blah blah blah, which goes forever. All these non-terminating, non-repeating decimals are members of the irrational numbers. We have already looked at the 5 sets of real numbers, so you might ask me, are there numbers that are not real? The answer is yes. If numbers are not real, they are not fake, but they are imaginary. All these imaginary numbers are not belonging to the real number system. They are belonging to another number system, which is known as the complex number system. And you are not responsible for these so-called imaginary numbers. For example, if you take the square root of a negative number, you will find that if you punch this in your calculator, you get an error for this square root, because the square root of a negative number is not a real number. But at this moment, just forget about this kind of number. They are out of the real number system. Now it is time to look at a general summary of what we have learned in this class. So we have looked at real number system in this class. Okay, so actually real number system is part of the complex number system. And the complex number system contains two sets of numbers. The first set is the real numbers, and the other set is the imaginary numbers. Okay, and we are only responsible to the real numbers only. So we look at this little box here, and in this class we have looked at the 5 sets of real numbers, which contains rational numbers and irrational numbers. So dichotomically, the real number set was being divided into rational and irrational. So rational numbers are not irrational. On the other hand, irrational numbers are not rational. And for rational numbers, they are further divided into 3 more layers. The first layer is the integers, the second layer is the whole numbers, and the third set is the natural numbers. This is basically the summary of what we have learned in this class. Now let's look at some examples of each set of numbers. Remember, for natural numbers, all the counting numbers belong to the natural number set. So 1, 2, 3, 4, 5, blah, 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 until very, very large. All these whole numbers are natural numbers. However, 0 is not considered as part of the natural numbers. It is belonging to another set of numbers. Remember that? So where should 0 be situated? Okay, 0 is part of the whole number system. So the whole number system contains 0 as well as all the natural numbers. Okay, remember that? Then for the negative side of all the natural numbers, they are part of the integers. So integers contains all the negative whole numbers, 0 as well as all the positive whole numbers. Okay, so if the number is not a whole number, for example, for fractions, all fractions are rational numbers, as well as 2 kinds of decimals. Remember that? The first one is the terminating decimals, such as 0.25, because you can simply write 0.25 as 1/4. Also, repeating decimals. Okay, in this case, it is 1/3. Okay, you can write it as fractions. So they are essentially rational numbers. Then for other kinds of decimals, such as non-terminating, non-repeating decimals, such as the root of a non-perfect square, they are irrational. And for mathematical constant pi and e, okay, all these are irrational numbers. Then for imaginary numbers, if you take the square root of a negative number, then you will end up with a number that is not real. In this case, this is a member of the imaginary number set. So now it is the most exciting part of this class. Okay, I like doing examples as well as exercises. Okay, so because it helps consolidate our knowledge. Okay, so when I look at this example, okay, in this example, you have to put a tick in a table wherever applicable. For example, 1. 1 is part of the real number system because all the numbers, remember, except the square root of a negative number are not real numbers. All the other kind of numbers are all are real numbers. So 1 is a real number. So is 1 a natural number? Okay. Remember, 1 is a counting number. It's a counting number. So it is natural. We learned it since we were a kid. Okay, for counting. So we put a tick for around the natural numbers. So how about, is it a whole number? If it is natural, then it is part of the whole number set as well as the integer set. So you have to take all 3. Because if it is a natural number, it must be part of the whole number because the whole number set contains 0 as well as all the natural number. So you have to take whole numbers. And the integer set contains all the whole numbers as well as the negative side of it. So if it is a whole number, it must be an integer. Okay. How about is one rational or irrational? Because rational and irrational divide the real number system dichotomy into two sets. So you have to take either one only. If a number is rational, then it must not be irrational or vice versa. Okay. So as I mentioned, all the integers can be written as fraction because you can simply override by 1 in order to change it to a fraction. So all the integers must be rational. So take around a rational number. Oh, so we are done the first one. How about 0? Okay, 0 is a real number, but is 0 a natural number? I mentioned before, 0, the concept of 0 is not natural, so it is excluded from the natural number set. But is 0 part of whole number? Yes, because 0 as well as all the natural numbers form the whole number set. So 0 is part of the whole number set. And is 0 part of the integer set? Yes, because 0 as well as all the positive whole numbers and negative whole numbers form the integer set. So 0 is part of the whole number set. Is 0 rational? Yes, because you can write 0 as a fraction simply by overing it by 1. So it is rational. Okay, we have done 2 of them already. How about the third one? Okay, this one is a non-terminating decimal. So it is a real number. And we don't have to take all these 3 because these 3 are monopolized by whole numbers. It is obvious that this one is not a whole number, so we don't have to take all these 3. We just have to determine whether it is rational or irrational. Then we are done with this question, with this number. And it's obvious that it is a non-terminating, non-repeating decimal, so it's irrational. Okay, irrational. Very good. Let's continue. Okay, -10. Is it real? Yes, it is real. Because there is no root sign around it, so it's real. Is it natural? No, because it's a negative number, so it is not natural. Is it a whole number? No, because whole number consists of 0 as well as all the positive whole number. However, this one is a negative, so we don't have to take whole numbers. Is it an integer? Yes, of course, because integer contains all the positive and negative whole numbers. And is it rational or irrational? Is it rational or irrational? It is. It is an integer, so it can be written as a fraction by overing it by 1. So it is rational. Then for pi and e, it is very simple. It's obvious that, okay, first of all, they are real. And since they are decimal numbers, so we don't have to care about these 3 columns. We just have to determine whether they are rational or irrational. So pi. Is pi a terminating decimal? No. Remember the guy who tried to dictate the decimal version of pi? No matter how many blackboards he used to dictate out the number, he still can't write out accurately the whole number. So it is irrational. And this is also the case for e. So we are done with the first part of this practice example. Now let's look at the second part of the practice example. There are 6 more. Then we are done with this question. Okay, this one, 1/3. Okay, 1/3 is real number. Okay, so taking the real number, Since it is not a whole number, so we don't have to consider these three columns, right? Then 1/3 is a fraction. So is it a rational number? Yes. All fractions are rational numbers. So 1/3 is part of the rational number set. If it is rational, then it is not irrational. Okay. So second one, 1.33333. Okay, which is a repeating decimal. Okay. So for all the repeating decimal, you can write it as a fraction. So in this case, it is equivalent to 1 1/3. Okay, which is a fraction. So all the fractions are rational number. And you can ignore these three columns because it is not a whole number. Also, it is part of the real number system. Then next one, 99999. It seems that, okay, first of all, it must be a real number. It seems that it is not a natural number because it is so big. But remember that the set of natural numbers contain whole numbers from starting from 1, 2 until very, very large. So 999 is a natural number. Okay. If it is natural, then it must be a whole and integer. And if it is an integer, it must be a rational number because you can write it as a fraction simply by over it by 1. So it is rational. So 3 more to go. This one, root 9. Fortunately, 9 is a perfect square, so you can compute the square roots. You can simplify the square root of 9 as 3, because 3 times 3 equals 9. So root 9 equals to 3. In the next section, in next video, we are going to look at a perfect square. So we'll learn more about perfect square in the next lesson. And 3, of course, it is a real number. So is 3 a natural number? 1 apple, 2 apples, 3 apples is a counting number, so it's a natural number. So if it is natural, then it must be whole and integer. And all the integers are rational numbers. Remember that? Okay, this one is a fraction again. Fraction it's the easiest one because immediately you can determine it is rational. And ignore these 3 columns because they are not whole numbers. And it is a real number as well. Okay, the trickiest part is here. You have root -2 here. So, is it a real number? Think about this. Is it a real number? The answer is no, because as mentioned in class, it is if you have a square root of a negative number, it must be it is imaginary. Yeah. So it is not a real number. So if it is not part of the real number, then it must not be belonging to all these 5 sets because these 5 sets are part of the real number system. If it is out of the real number system, then you don't have to take any of these sets as well. So basically, we are done with this question. This is the end of this video. I hope everyone have enjoyed the first chapter, a very exciting chapter, the real number system. If you like my channel, please give me a thumbs up, comment, share, as well as subscribe my channel. Thank you very much, and I will see you in tutorial 1.